So, Ex5J, so far, what have we done? We've learnt algebra, we've learnt how to factorize, dops, complete the square, all of which is to help you sketch. If you think about it logically, it's only to help you sketch. Now, to sketch a parabola, there were three things that you need. What were they again? Name me one, Jaden. What do you need when you're sketching a parabola? What do you need? Turning point. What else do you need? What else do we need? Y-intercepts. Thank you again, Jaden. Let's go with Joanne. X-intercept. Out of them all, the easiest one, if I had to rank, it would be y-intercept's the easiest because you let x equal to 0. Turning point, there was a formula that I gave you, and this is where I said, just don't question, just listen, just do what I tell you. X equals negative b over 2a is one of the formulas to find your turning point, the x coordinate of the turning point. So I would say this is the second hardest one just because you have to remember what you need to do or why you do them. X-axis intercept to me is what the mainstream and most students generally struggle. And the reason for that is because in order to solve a problem that is something like a trinomial, so let's say ax squared plus bx plus c, the problem is linear was easy. When you only have one x, you can reverse everything and solve for the one thing that you don't know. When you have two that you can't cancel out, it becomes a problem. That's why the only technique you can do to find the x-intercept is when you let y equal to 0, the only way is that you have to see if you can factorize into two brackets. That's one of the ways to do it. And then you use null factor law. So you can see there's a couple of steps here. Null factor law to solve. But what if you can't do cross method or grouping method to then solve to get to null factor law? Then you learn completing the square. So that's combining 5D, 5E, 5G, 5F, 5I. That's pretty much all just to find an x-intercept from chapter 5. If you can't do any of those, or especially DE, then you definitely won't be able to do F and I. And therefore, you definitely can't do G because you can't get to this point. So it locks most of the mainstreamers, it locks this out. And so it's like, well, how do you sketch them? Because you'll never be able to get the x-intercept, but you only get the turning point and the y-intercept if they even get to the point where they remember the rule for the turning point. So most times they get 1 mark out of 3. Quadratic formula is your last technique. In the worst case scenario, if you couldn't do exercise 5DEGFI, it's probably a hint not to do methods. And that means that algebraically that's a bit challenging for you. And so from there, this is another way. So you can get through, still get your S in year 10 and year 11, you can get your S's, but it means that I wouldn't recommend for you to do it in year 12. I would just say that means there's a cap or the amount of effort you need to do more to learn the basics. Yeah? This rule here is called your quadratic formula. You are meant to memorize it. You are meant to know it off by heart. At year 9 and 10, usually it is in the formula sheet, but by the time you get to year 11, that is prerequisite knowledge. Yeah, so negative b plus minus square root of b squared minus 4ac. What is b, a, and c? They all represent each of the coefficients of a general quadratic equation. So even if you don't know how to factorize, this formula will tell you the x-intercepts. So you didn't even have to factorize, don't have to do null factor law. Plug it in here, and you will get the x-intercept. Fill that in. The reason I want you to fill it in is because I want you to know that this x is not the same as x equals negative b on 2a. These two are very different. This x tells you the x-coordinate of the turning point. Okay? This x actually tells you the x-intercepts of the equation. So even if you can't factorize, if you're in a test condition and you're fumbling, you forget the cross method, you can't do completing the square, then at least you've got a formula that then solves the x-intercept and you can still sketch this graph, get 3 out of 3 marks. Yeah? And knowing that it's the x-intercept also will help you analyze. So the next part where I'm going to teach you to analyze the function, understanding it's the x-intercept is key. So let's do an example. So you've got a rule. A, B's, and C's. A is the coefficient of x squared, B is the coefficient of x, and C is a constant term. Let's do an example. Here we go. 3x squared minus x minus 4. What is my value for A, B, and C? Let's start with A. Can I please have? Let's go with Rowan. What's the A value in this equation?
I think it's 3.
It is 3. That is correct. Write it in. So A is 3. Sam, what is B? This equation? So B is the coefficient of x, meaning the number multiplied to -1. Very good. C is the constant term. What is the constant term? Let's go with Toby. We've got 3x squared minus x minus 4. Which one's C? It is, but be careful with the negative as well. It is -4. Let's apply the formula. So here we go. Formula is -b plus minus the square root of b squared minus 4ac all over 2a. So here, if your layout is clear, usually you wouldn't make a mistake. So sub it in. It's negative of -1 plus minus the square root of -1 squared minus 4 times a, which is 3, times c, which is -4. Notice my layout? I use a lot of brackets. I do it so that I don't make mistakes, just because I tend to make mistakes with negatives. 2 times a, which is 3. Let's simplify that. Double negatives is positive, so you end up with 1 plus or minus the root of -1 squared. What is that? 1. Very good. So 1. -4 times 3 times -4 again. They should give you not 46. 48, yes. So it's positive 48. Double negatives is positive. So -4 times 3, or -4 and -4 is positive 16. 16, triple of 16 is 48. 1 plus 48 is clearly 49 there, but then over 2 times 3, which is 6. So that tells me the x-intercepts can be at 1 plus or minus root of 49 over 6. Now that plus or minus for the mainstreamers, the first time they see it, it gets a bit scary, but all it really means, so you have 2 possible x-intercepts. You have x is equal to 1 plus root of 49 is 7 over 6, or your second x-intercept could be 1 minus 7 on 6. So root of 49 is 7. You get either a positive answer or negative answer. And then here you get 2 very distinct answers. It's either 8 on 6, which is the same thing as saying 4 on 3, or 1 take away 7 is -6. -6 on 6 is -1. So those are my 2 x-intercepts without doing any factorizing. All I did was I just took the coefficients, sub it into the formula, and I get this. So part of your exercise so far, the year 10s, mainstream, this is what they practice. Part of it is to know how to use the rule. Part of it is to understand how to identify A, B's, and C's. Yeah? Is that easy so far? Yeah, so the purpose of this formula is to find x-intercepts. That's when you can't do factorizing and you don't know how to complete the square, then you got this rule to do. Now, before we get on to the proofs, let's flip over the page so that you can see where this logic comes in. Okay, so this is to find the x-intercepts. We'll come back to the proof soon. The second part of your exercise, so one is how to use the rule. Second one is the analysis. Now, they usually don't tell you the analysis. They tell you to memorize this. Write this on the side. Do a little box on the corner. They usually call this topic is called discriminants. And they use a triangle to mean discriminant. And they say discriminant is equal to b squared minus 4ac. They tell you to memorize these 3 conditions. Condition 1, if discriminant is greater than 0, 2 solutions. Condition number 2, if discriminant is equal to 0, 1 solution. Condition number 3, if discriminant is less than 0, 0 solutions. Most students will memorize that. And that's what I hear when they come into year 11 methods and I say discriminants, they're like, oh, something about greater than 0, equal to 0, less than 0. I'm like, great, so what does that mean? And then some of them will say something about 2, 1, and 0, but they don't actually understand what it is. So today, I want to spend this bit here just to get you to understand logically, why are these conditions there? And you don't have to memorize it. In fact, it was just your quadratic formula to understand. So, let's highlight it. When they say discriminant, they use the little symbol called triangle, but b squared minus 4ac, where do you see that in the formula, in the quadratic formula? In the root. Right here. Why is this powerful? So they, instead of writing b squared minus 4ac, they just said whatever that equals to, they put a triangle. Now, whatever that equals to has a very powerful impact on x. See, x represents the possible intercepts. Now, the possible intercepts, there are 3 scenarios that your quadratic can have. You can have a quadratic that has 2 x-intercepts. That's 1. That's 2. But then you can have a quadratic where it doesn't have any intercepts at all. So that's 0. Or you can have a quadratic that sits exactly, the turning point sits on the x-axis, so hence you only have 1. 1 intercept, no intercept, 2 intercepts. This is what those numbers represent when they say 2, 1, and 0. 2 solutions means you end up with 2 intercepts. 1 solution means that you end up with 1 intercept. And 0 solutions or no solutions just means no x-intercepts. So that makes sense graphically. But why does it work algebraically? Well, let's think about it. So the rule, you have a plus and a minus. You're either adding on the whatever you're square rooting, or you're subtracting whatever you're square rooting. So this bit here, the only difference is when you add or subtract whatever that root is. Now, if you think about it, what is the limitation of a square root? What can't you square root? Negatives. This is why whatever b squared minus 4ac is, if it ends up being a negative number, if it's negative, if b squared minus 4ac is a negative number, you can't square root a negative number. If you can't square root a negative number, then you can't add or subtract a number at all because there is no number for you to figure out. So that means you can't find x-intercept. But it doesn't mean you've done anything wrong. It just means maybe there is no x-intercept. That's why you can't solve it. So that's why they say, for this scenario, no solutions. That occurs when the discriminant, which is the b squared minus 4ac, or whatever you're square rooting, if whatever you're square rooting is less than 0, but less than 0 just means negative, doesn't it? So they're just telling you, if you square root and it's a negative number, of course, you can't square root it. You end up with something like this. You end up with x equals negative b plus or minus square root of a negative number divided by 2a. That's a problem. That already is an error. Right there is an error. So of course you won't have an x-intercept, so hence no solutions. So that would belong to this scenario. That's why you don't have to memorize it. It just makes sense. Just look at the square root sign. How is it possible to get one solution? See, if you think about it logically, one solution would mean that the discriminant, they say discriminant has to equal to 0. Well, why is that? Well, the only way that's going to work is if you did x equals negative b plus minus, if you rooted 0. What's the square root of 0? 0. But if you add or subtract 0, it doesn't make a difference. If you took 3, take away 0, or 3 plus 0, you still get the same answer. So instead of getting 2 different answers, you end up with 1 answer. But if you get 1 answer, then that's 1 intercept. That's why that works. It's not just a thing that we tell you to memorize, but it actually just makes sense. That's the only time where you add or subtract doesn't change the answer. The answer still stays as negative b plus minus 0 over 2a. So the answer actually ends up being negative b on 2a, which is the turning point, which is the formula I gave you. Negative b over 2a. It's the x corner of the turning point, which makes sense. So hence why that's one solution.
Just a little bit unrelated, but like, what if you have like no intercepts at all? Like, hypothetically it should be possible.
To have no intercepts at all?
Wait, no, I mean apart from y intercept. But, like,
Yeah. So you can have a scenario where there is no x-intercepts at all, but yeah, you have to have a... No, you're not. It's a good question.
Well, then it has to like go up at some point.
Yeah.
It goes
Yeah. It goes infinitely. So you're right. Eventually, there will always be one intercept. Yeah. Very good. And the last one, which hopefully by now you'll understand why they say two solutions. Well, logically, it says discriminant greater than 0. Why is that? Because you're saying negative b plus minus square root. If it's a positive number, whatever that number is, when you square root it, of course, you're going to get two scenarios. You add it or you subtract it. Of course, you're going to get two different answers. That's why you end up with two different answers. And they just gave a name to this. They call it discriminant. Because the discriminant is also a quick way for you to know, are you going to get 1, 0, or 2 possible solutions or intercepts, essentially. So let's do this one as an example. So now that you understand the theory, you see, you don't actually have to work out the full quadratic formula. You can sort of start off by saying, well, will it have any intercepts? You can do completed square to find out, or discriminant. So when I say how many solutions are there, I'm asking how many x-intercepts would this graph have? And a quick way to do it is just to look at the square root, which is b squared minus 4ac. So let's work it out. Discriminant, which is b squared minus 4ac, let's see what it actually ends up being. Is it positive? Is it negative? Or is it 0? What's my b in this case here? What's b equal to? 7. Good. So it should be 7 squared minus 4 times a, which is 1. C? Negative 1. So put it all together. 7 squared is 49. 49, negative 4, negative 1 is plus 4. You don't even need to know the answer because we don't care about the answer. We only care if it's going to be two solutions or not. 49 plus 4, of course, is going to be 2. So I expect this graph, x squared plus 7x minus 1, if you type it on Desmos. I know, another endorsement for Desmos. If you type it in, you should get two solutions. What about the next one? Let's have a look. A, do it again. Oh, what's going on with my pen? Here we go. Discriminant. So this one should have two x-intercepts, which you can find out by doing the quadratic formula. Discriminant, b squared minus 4ac again. B, what is b in this case? For the second scenario, what's my b? Negative 1 minus 4 times a, which is 3, times c, which is 2. You get 1 minus 4 times 3 is 12. 12 times 2 is 24. I can already tell this is going to be a negative answer. But if it's a negative answer, the problem is you can't square root a negative later. So therefore, there shouldn't be any x-intercepts at all. So, no. So when they say solve for x, there's no point. You don't need to. You know this graph is not going to touch the x-intercept. So at a year 10 level, this is all you need to know. Formula, which is usually given to you on a test, how to use it. Understand the three conditions. I don't want you to memorize it. I want you to analyze the actual quadratic formula. So how does this problem become trickier? So at a year 11 level, for those who are interested, you can see if you can think about this one. What if I gave you this problem? What if I said, I've got an equation, ax squared plus ax plus 2. Tell me what numbers of a, because you can change a to whatever number you want, but what numbers of a will give you one x-intercept? Is it possible? That's the year 11 level. So when you come in at year 11 methods, by the 7th week, after you revise all the way up to this point, the next exercise challenges you on this part. And that's where a lot of students struggle because, one, they don't understand the discriminants to begin with, but then to figure that one out, you can trial and error, but we're not about trial and error, we're about solving it. So there is a technique to analyze and solve.
AX have to be 1, because like 1 squared equals 1 plus, no wait, I mean negative 2. I'm thinking too much. Yeah.
You can try it on Desmos. And so you can type in ax squared plus ax plus 2, and there's a slider for a. As you change the a values, you'll see how it changes the graph. You can probably estimate roughly what would a have to be to make sure you get one solution. You can even change that question. What if I said 2 x-intercepts? Or I change that question to 0 x-intercepts. What a values will guarantee that? That's at the year 11 methods level where you're analyzing. But to the analysis, you need to know the skills beforehand. So today's lesson is only just the skills, but for those who are interested, you can try that one out. Okay, so that's a question you can play. Tell me, is it possible to get 1? Or did I make up a question that may not even be possible to get 1? Okay, so I'm going to stop the video there.